Hello everyone, welcome to our weekly series of CBSE Class 10, and today we are proceeding with Part 4 of our Chapter 3 Pair of Linear Equations in Two Variables. We have already completed Part 1 to 3 for the same chapter, wherein we have covered all the necessary topics to solve the exercises from the CBSE textbook. In this particular part, we are going to solve some additional practice questions from the exam point of view. As part of this series, we have already covered Chapter 1 and Chapter 2. I'm sharing their link in the description. Make sure to watch them as well. Let's move further. The first question is, solve the following systems of equations. The equations are 99x plus 101y is 499. This is the first equation. And 101x plus 99y is 501. We can solve this equation by both substitution and elimination method, but when I observe this question very carefully, I see that it is a special case of linear pair of equations. Why special? Here I can see the coefficients of x and y in equation 1 and 2 are same, that is both are 99, and coefficient of y and x in both the equations is also same. So if we are having the coefficients of x and y interchanged in both the equation, it becomes a special case, and then there is a shortcut method to address such questions. What is the method? Let us see. First, we start by adding the equations. We get 200x plus 200y is equal to 1000. Now, in the entire equation, I can see 200 is a common factor. So, we divide the whole equation by 200. On dividing the equation by 200, we get x plus y is equal to 5. This becomes equation number 3. Then we subtract the equations. So we get 99x minus 101x will become minus 2x. 101y minus 99y will become plus 2y. And 499 minus 501 will become negative 2. Again, I can see in this equation 2 is a common factor. So we again divide the equation by 2. We end up getting minus x plus y is minus 1. This is my fourth equation. Now, rather than solving equation 1 and 2, we will be solving 3 and 4. Now, as I can see here in third equation, x is positive, and in the fourth equation, x is negative. So if I add them both, the x will get eliminated. So by adding 3 and 4, we get x gets eliminated, y plus y becomes 2y, and 5 minus 1 becomes 4. So we get y is equal to 4 divided by 2. So y is equal to 2. Now, this value of y we can put in either of equation 1, 2, 3 or 4. We put this in equation 3. Therefore, x plus 2 is equal to 5. We get x is equal to 5 minus 2, which is x is equal to 3. Therefore, the pair of equations given, the solution becomes x is equal to 3 and y is equal to 2. I hope this method is understood, and we have applied elimination method after reducing the special case of the equations by first adding them and by then subtracting them. Let's see the next question. The next question says, find the value of k for which the following pair of linear equations has infinitely many solutions. The equations given are as follows. Now, first of all, for infinite solution, the condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So how do we start? We start by first writing down the values of a1, b1, c1 and a2, b2, c2. We get a1, the coefficient of x, which is 2, b1, coefficient of y, which is 3, and c1. Here I see that the constant terms in both the equations are on the same side. If they are on the right side, that is also okay. If they are on the left side, both together, that is also fine. So here, both the constants are on the right side. So we get the value of c1 as 7. Similarly, we get a2, which is the coefficient of x as k plus 1. b2, which is the coefficient of y, which is twice k minus 1, and c2 is 4k plus 1. Now we need to find the value of k, and since all the three ratios are equal, we can take any of the ratios. But just for clarity's sake, we will take two ratios and we will check whether we are getting the same value of k or not. So let us see, a1 by a2 is equal to b1 by b2. We get 2 over k plus 1 is equal to 3 over 2k minus 1. On cross multiplication, I will get 2 times 2k minus 1 is equal to 3 times k plus 1. Further open the bracket. 4k minus 2 is equal to 3k plus 3. Moving the k terms on the same side and the constants on the other side, we get k is equal to 5. If this question is asked in the exam, we will solve only till here. But here, for the explanation point of view, I am solving it with another ratio as well. Let us take a1 by a2 is equal to c1 by c2. We have 2 over k plus 1 is equal to 7 over 4k plus 1. On cross multiplication, twice 4k plus 1 is equal to 7 times k plus 1. Open the bracket. 8k plus 2 is equal to 7k plus 7. Collect the k terms on one side and the constants on the other. Here also you can see we are getting k is equal to 5. So the value for which the following pair of linear equation will have infinite solutions is k is equal to 5. I hope this is understood. Let's move further. The third question is solve the following systems of equations for x and y. The given equations are ax plus by is a minus b and bx minus ay is a plus b. This is my first equation, this is my second equation. Now if I am trying to solve it by elimination method, I can make the coefficients of either x same or either y same. I will try to make the coefficients of y same. How can I do that? I can do that by multiplying equation 1 with A and equation 2 with B. So A with equation 1 and multiply equation 2 with B. We get A square x plus ABY is equal to A square minus AB, B square x minus ABY is equal to AB plus B square. Now add equation 3 and 4. On adding 3 and 4, what we will get? On the left side, I can see this is positive ABY, this is negative ABY, which will get cancelled. So we will be left with A square x plus B square x on the left side. On the right side, I can see minus AB and plus AB will get cancelled. So right side, we will get A square plus B square. I take x common, a square plus b square on the right side. Therefore, we get x is equal to a square plus b square divided by a square plus b square. We cancel the entire terms, we get x is equal to 1. This is the first solution. Now, we put x is equal to 1 in either of the equations, so I'll put it in equation 1. Therefore, a times 1 plus by is a minus b. A plus by is a minus b. By is a minus b minus a. This is cancelled. So we are left with b is equal to minus b by b, which is minus 1. Therefore, for the given pair of equations, the solution is x is equal to 1 and y is equal to minus 1. I hope you people are understanding and trying to solve it along with me. Let's move further. The next pair of equations is solve the equations graphically. So here we have been asked specifically to find the values of the solution using graphical method. Let us see how we will do that. We will start by finding a pair of points for the given equations. So for the first pair of equations, I want to find at least one pair of x and y. How can I do that? I will take x is equal to 6 minus 2y. For different values of y, I will find different values of x. So let us see for y is equal to 0. When y is equal to 0, I get the value of x is equal to 6. This is my first point that I'll be plotting on the graph. For the second point, y is equal to 3. When I put y is equal to 3, I get x is equal to 6 minus 2 times 3, which is 6 minus 6, which is 0. So the second point which I get is x is equal to 0 and y is equal to 3. Similarly, we will find the pair of points for 2x minus 5y is equal to 12. 2x becomes 12 plus 5y and x becomes 12 plus 5y over 2. Now I need a pair of values of x and y. For the first case, I will put y is equal to, let's say, negative 1. So when I put y is equal to negative 1, I get x as 12 minus 5 by 2, which is 7 by 2, which is 3.5. So the first point I get is 3.5 and minus 1. For the second, I'm taking y as negative 2, which makes x is equal to 12 minus 10 by 2, which is 2 by 2, which is 1. So the second pair of points that I get is 1, minus 2. Now let us plot these points on the graph. Now this is my graph. We start by first plotting the values for the equation 1, which is 6, 0 and 0, 3. These are the points. This is 0, 3 and 6, 0. We join them with a straight line and we get the graph for x plus 2y is equal to 6. Now I'm trying to plot the graph for the second equation 2x minus 5y is equal to 12. Let's plot the points. The first point is 3.5 comma minus 1, which is this point. The second point is 1 comma minus 2. Let's join them together. This is the graph for 2x minus 5y is equal to 12. As we can see, both the lines are intersecting and they are intersecting at 6, 0. Therefore, x is equal to 6 and y is equal to 0 becomes the solution for the given pair of equation. I hope even this graphical method is clear. Let's move to the last question. Place A and B are 100 km apart on a highway. One car starts from A and another from B at the same time. If the car travels in the same direction at different speeds, they meet in 5 hours. If they travel towards each other, they meet in 1 hour. What are the speeds of the two cars? We are supposed to find the speed of the two cars. So let speed of car at point A is x km per hour and speed of car at point B is y km per hour. Let us see the first case. The first case says if the car travels in the same direction at different speeds, they meet in 5 hours. So here as you can see in the first figure, both the cars are moving in the same direction and when they travel for 5 hours, they are going to meet at a point. So assuming that they meet at a point C. Now, since distance is equal to speed into time, so the car at point A, which is traveling at x km per hour, if it is traveling for 5 hours, so the distance traveled by car at point A becomes speed into time. Speed being x km per hour and time being 5 hours, the distance traveled is 5x. Similarly, the car at point B is also traveling at y km per hour and it is also traveling for 5 hours. So distance traveled by car at point B becomes 5y. Now as I can see from the figure, AC is the distance 5x, BC is the distance which is 5y, and from the figure we can see AB plus BC is equal to AC. AB is how much? AB is the 100 km distance between point A and B. BC is the distance 5y and AC is the distance 5x. Therefore, we get 5x minus 5y is equal to 100. And as I can see, 5 is a common factor. So on dividing by 5, we get the first equation as x minus y is equal to 20. I hope this method is understood. Now let us see case 2. In case 2 also, the speed of the car at point A is x km per hour and the speed of car at point B is y km per hour. Now, they are both traveling towards each other and they meet in 1 hour. So, suppose they are meeting at this point, which is, let's say, this point is C. So, distance traveled by car at point A is speed into time. Speed is x and time is 1. That is, after 1 hour, distance traveled will become 1 into x, which is x. Similarly, distance traveled by car at point B becomes 1 into y, which is y. Now, as we can see from the figure, AC plus BC is equal to AB. From the figure, AC distance is x, BC distance is y. So, we get x plus y is equal to 100. This becomes my second equation. Now we have two equations to solve. I can see the coefficients of y are both 1 but the signs are opposite. So I'll add equation 2 and I'm naming it as 3 here. On adding 2 and 3 I get 2x is equal to 120. Therefore x is equal to 60 km per hour. Now put x in, let's say, equation 2. We get 60 plus y is 100. Therefore y is equal to 40 km per hour. Therefore, speed of car at point A is 60 km per hour and speed of car at point B is 40 km per hour. I hope this question is nicely understood. Let's move further. Now, these are some additional practice questions. These questions are similar to the kinds that we have done in today's session as well as in part 3 of the linear pair of equations videos. You can screenshot these questions, solve them, and the answers to them are shared on the next page. The solution to these questions will soon be shared. Screenshot the questions now. Now, screenshot the answers as well. Hope